start recording too. Okay. So number one, basically identify which atom or bonds are part of the hydrophilic region of the structure. So this is also like kind of like how soap is. The polar part is the hydrophilic part. So like, I think just anything right here you could identify. Okay. So there's that one. So yeah. For number two, which is the stronger base. I'm pretty sure this one is going off of Aereo, right? That kind of stuff.
That's what I used. I don't know if it's right.
Yeah, so BR is larger, right? And then fluorine also.
Desiree, sorry.
Mhm.
In her office hour, she explained it's because of electronegativity.
Oh, okay. I'm not too sure which part of area that is, but yeah. Oh, yeah. I think larger only applies if it's charged, or like the size. So higher electronegativity with BR.
Roshan, did she explain why it's electronegativity?
She explained because B is strong base because it's less stable. Because fluorine, I think, yeah.
But wouldn't it be if it has a higher electronegativity, or even if it were a larger ion, doesn't that make it more stable?
Maybe it's correct with size, but she explained with electronegativity.
Okay. Did she say that the one with BR was the correct answer?
Yes, B is the correct answer.
Oh, yeah.
Because I answered A, she
Mhm.
said no, the B is correct answer.
Yeah, I just found that on my notes too. So yeah, that's the A part of Aereo. So yeah.
But A is if they're in this, what is it? There's like the same row and same column.
Yes. So this one's
Are they going off
no,
of
this one.
BR and F? Because they're same column.
Yeah, they are in the same column. Okay, wait.
It's confusing.
Yeah, I just found that too. That's weird. Because either way, I guess on this flashcard specifically, I have written down that the more electronegative atom is the strongest base, but that's still under the A part of
Is
it.
most electronegative atom, I gotta go back and look at that, because if you were to find the conjugate base and then you go off of most electronegative atom, wouldn't we put like, so that would make that base more stable, which makes it a weak base and a stronger parent acid? That's how we would do that, right? That's how I.
Yeah, I'm not sure. Which one is the one about the column?
Sorry, and also she explained COO more polar and negative. Because I answered A, because of that I confused. Honestly, I'm not sure. How can I explain? But her answer was B.
Okay. I just wish that we had a full explanation for it.
I don't know how to make this one make sense. Because yeah, I don't know.
Let me see if I can
Does she have another office hours tomorrow?
Oh, yeah, well, yeah, I think she does have them on
Okay.
Wednesdays also.
So if
We
it,
can
if
ask
the
her.
charge is on the same atom,
Uh-huh.
maybe it's
Oh,
resonant.
yeah, A
but
is for
that would
charge
be
on
the
different
same.
atoms.
So you would do off of that inductive in whatever the I in REO.
Yeah,
So
yeah.
that's actually
So
what
then
you would use.
that just means that this one
So that's
is
what Roshan means by electronegativity. Okay.
okay.
I
Yeah,
couldn't,
this one
I
does.
just couldn't make it make sense.
Yeah, okay.
So that makes sense now.
Oh,
Do people get that now? Okay. That's why. Mm.
mm,
So that makes sense now. So because the charge is on the same atom, you use the induction rule, which is like whichever atom is more where the electronegativity is going to be pulling more. So fluorine is more electronegative than bromine.
I just confused myself thinking about it more because I thought what happens with induction is that this delocalizes the charge, which makes it more stable. I thought it made it more stable, I guess.
Yeah,
when
but
it
the more
delocalizes.
electronegative it, because it's going to be pulling more.
Uh-huh.
So it's more stability. Like, so the bromine's not pulling away as much as the fluorine from the carboxylate ion.
Oh, it's not? I thought that the bromine was pulling more than the fluorine. Or is it the other
Or
way?
which is no, I am confused. Because what isn't fluorine more electronegative?
No, bromine is more electronegative. Because, well,
Oh,
I'm pretty
yeah,
sure
it
this
is,
is,
I guess, huh?
isn't
That's
this the way
the-
electronegativity goes on the thing? Oh,
Mm,
shoot.
I
Wait,
think it was
it's,
up, like to up and to the right.
oh, you thought it was,
Yeah, I think it's to the right and then upward because fluorine
oh,
is negative.
okay.
I don't think I have it written down.
Oh, but you said up and to the right. Oh, ew, I have it written really weird on my periodic table. Okay. I think, okay. Okay, wait, so
Yeah.
then, so we're confirming that fluorine is more electronegative than bromine?
Yeah.
Okay.
So charges on the same atom and same number of resonance structures, you do induction. So the greater EWGs is most stable, which is more electronegativity, is more induction. That's what I have written down.
Wait,
So it, I don't, so I'm like still getting F. I don't know how professor's getting B.
For this one, I think it's because the F has a higher electronegativity, so it's withdrawing the negative charge from the oxygen more, and so it makes it more stable.
Oh, right. Oh my gosh. I'm so sorry. Thank you, Natalie, because we're trying to find stronger base. So A would be the stronger acid
yeah.
and weaker
Yeah,
conjugate.
I got
base.
Exactly.
Okay. I'm sorry.
Ooh, okay, cool. So,
I
yeah.
answered the same logic, but
Wait, this is
she
a-
explained, she asked about stronger base.
That's where it's the base. So it's because it's least stable. This base is least stable. So it has least
Mhm.
electronegativity, least stable, which is stronger base, weaker acid.
Yes. Yes. Cool.
We did it. Good job.
I know. I was like, we all contributed to that one. That was awesome. Cool. Okay. So there's that one. rank in order of acid strength. This one, I don't know if I'm too sure which part of area we're using.
I have no idea how to do this. Is that what we're probably doing too?
I think so, because well then I guess we would, because that's the only way I know how to do it is to find like the conjugate base, and then you just like compare what's going on. Charges on the same atom. So it's not like A. And then do they differ in resonance structures? I don't think so, because they all are like single bonded. Or actually, I don't freaking remember how resonance works.
I feel like we had something similar to this on on one of the previous quizzes we took.
Yeah, one of like first ones.
But I don't know. I don't know how to go about this one.
Okay.
This is the one I got. I was like, I don't know what we're supposed to pay attention to, because usually you pay attention to like the carbon, if it's primary or secondary, or what you're doing, like finding the conjugate, but like the placement of the chlorines is what's, because
Yeah.
there's 2 chlorines and all of the carbons are secondary, so that isn't anything.
Yeah, I was wondering if this one was kind of also induction, and if they just like pulled differently.
Oh, yeah. So that's what, okay,
You
so
think
the
so?
one in the quiz had like a fluorine, it had 1 fluorine, so like 1 fluorine was all the way at the end, one was closer
Oh.
to the charge.
Oh, that was a practice
Remember
quiz
that
or something, I
question?
think. Right? Or was it a practice quiz or a real one?
It was,
If
I think it was on an actual quiz.
Oh, yeah, if it was real
Or a
life, then we
practice
could
quiz.
find it.
Practice quiz. Let me see.
Yeah, I'll also look through the quizzes to make sure.
I didn't really get a chance to go through this, so that's I'm like going through it.
Yeah, no worries. Yeah.
It's weirdly chapter 2 heavy. for
I
being
know.
15.
Like I think like question on practice quiz 2 for summer 2020, number 3.
Uh-oh.
I think it's kind of like that.
Yeah, I don't have the work for those ones anymore because I lost the windows a while ago. Do you know, or well, I don't know, do you remember how we did it?
So so like we can draw the electronegativity arrows pulling towards the chlorines. You can kind of draw it like that, and then pulling towards the carboxylic acid.
Oh, and I'll figure it. That also?
Yeah, like that, I think.
I don't know if it really matters so much the direction is. That's fine.
So
Oh, I feel like, well, this one looks like it would delocalize the charge the most, right? Because they're all actually oriented in different directions.
So that would be most acidic, right?
Yeah, most stable at least, or well, stable.
Conjugate.
Yeah.
I think the last one would be least acidic because maybe they're all pulling down.
Yeah.
And the other one, there's like one's pulling down and 2 are pulling up. I don't even know if that's an accurate interpretation of this.
Yeah.
I have her answer if you need.
Oh, yes.
Yeah.
The first one from right side, it's the most acidic, number 1. No, from the, yes. No,
Oh, wait,
it's
so
1.
sorry, but this one is number 1?
Yes, it's
Oh,
number
dang
1.
Okay.
What? Okay.
I think that's what I
And
did
the
earlier.
middle one is 2,
Mhm.
and the other is 3. Because
Okay,
of,
that's-
again, because of the electronegativity, when it's close, more close, it's more acidic because the conjunction base is more stable.
okay. I did it earlier like that, but I really had no basis anyway. Okay. Let's see. Okay.
She explained two chlor stronger.
What was that?
Two chlor together,
Oh, okay.
like number one, is
Mhm.
stronger, and closer, again, is stronger.
Okay. And let me see if I can make this make sense, because if it's closer, I'm thinking it'll be more electronegative, which, yeah, means it's stable conjugate base, which means it's a strong acid. And then I think
That one
maybe what
further
happens is
below, or
as it gets further away, it's just like a little less electronegative. And then when it's furthest away,
trying to
it has the least amount of pull.
but I thought the more pull, the more more stable. Like
Yes,
it's like
but that's,
opposite, like pulling opposite. I'm confused.
yeah, I mean, I don't know if the actual orientations matter as much as I thought, but it
Even
is
the quiz too, it's not like that. It's you know,
okay.
the fluorine that's furthest away from the negative charge on the oxygen is most acidic.
Oh,
And
really?
fluorine that's closest. That's what I mean.
Oh.
Like I'm confused. I don't know how professors how to do these ones.
And is, oh wait, let me see. This one's also kind of similar, but that's on the practice quiz or the real one?
Yeah, 2020 summer. The first one that's up there.
Okay, let me see.
3.
Hmm.
Oh wait, I have different. Oh wait, no, you're never mind. You still have the same one on there. I thought you were pulling it.
Oh,
up.
sorry.
No, you don't have to. I just looked up and thought that's what was up there.
I'm looking at, I'm trying to see if it will make sense with the actual quiz questions, because we have the actual answers for it. But it's slightly different on the actual quiz, because yes, we have the answers. It's like, but then it's asking rate it like strongest to weakest base.
Oh,
But
that was
like
on the
the-
actual quiz, huh?
yeah, but the double bonds are like getting closer further. So I feel like it would kind of be the same thing. And then so
Is it resonance? No. maybe.
right. Oh, this one might be resonance. I hate resonance. I haven't attempted it in so long. This one ended up being strongest.
Somehow resonance.
I don't even understand
Based
that.
off of resonance, yeah, because the more
Oh,
bond,
okay.
yeah.
Oh, yeah. Okay, never mind. Not applicable then. Sad. Well, we can go ahead and ask about it tomorrow, and then yeah, just update.
She's got
But
something to
Roshan,
do.
you said that this is the answer that she gave.
Yes, this is the exact order that she explained.
Okay. Okay then. Yeah, we could go ahead and ask another time if we want to, so that we can all hear about it. But yeah, otherwise we can.
But still, I could be wrong. Maybe it's better we check with her tomorrow.
Yeah, exactly. So yeah, whoever ends up going, if you could put it in the Discord or something, what she says about it. Sorry, but we could go on to the next one then. So number 4 is the IUPAC name for this one. So we'll start at the carboxylic acid. Number 5. So pent and oic acid. Oops, acid. And then we have 3-methyl and 4-hydroxy. Whoops. And then in alphabetical order, H I to get yes. So H first. So 4-hydroxy, 3-methyl pentanoic acid. Yeah, and then I don't think there's any R or S or anything like that. Yeah, no. So cool.
Would any be oxo, or is it still
I don't-
hydroxy?
It's just hydroxy because it's an alcohol. And then oxo is for ketones and aldehydes. Yeah. That's 4. Then we could do 5. So predict the following, predict the product of the esterification reaction. So in esterification, it's like carboxylic acid reacts with an alcohol. And then it creates an ester. And then I noticed, or I mean, like, what's easy for me for this is it loses an OH from the carboxylic acid, and then it just loses an H from the alcohol. Okay. So for this one, predict the product. Let's see. So we would lose this, and then also this one. And then when they're on the same structure, then it reacts with itself to form a cyclic structure, whatever. So 1, 2, 3, 4. Let's see, how is that gonna work? Wait. 1, 2, 3, 5, I think also. Actually, no. Wait, do I use? It can't be 4. I got 5 last time. How am I counting wrong? I might have messed this part up. I'm so confused.
I think you're
I think
right.
it's
The O is in the ring as well. So that's like the
E.
5th.
Uh-huh. Wait, so then, yeah, just because I thought I would end up with a 5 right here, but I guess not. Because
Because I
the,
think the 5 is gonna end up a methyl.
like the way I have it.
E, yeah, because the oxygen, that the alcohol that lost its hydrogen,
Oh, wait, is there
That's-
carbon?
that's got to connect to the carbon 1.
Wait, which one?
Oh. The oxygen with
This
the
one.
next to the red X hydrogen.
Okay,
Yeah,
yeah.
that has to connect to carbon 1.
Exactly. That's what I thought, but then the way it's numbered right now, it would only have like 4. It
Yeah,
would, like,
so then your 5th would be it would be a methyl. It becomes a methyl. Like if you rotate it around, it's gonna be a methyl. So
I'm not
like,
understanding it for myself today, but
if
right now. I did it earlier. That's
so
so
if you
weird.
rotate
so.
the alcohol with the 5,
Mhm.
like if they were just
Yeah.
switch places and you made it one long carbon chain and then the hydroxyls down.
Right. Or- oh my god, I'm gonna kill myself. I don't know anymore.
I don't know how to.
That's okay.
So just
Is it
on
A
the
though?
on the compound, that's what I have, yeah. But on
Okay.
the compound you have, just for the sake of visualizing that what you have, just swap the carbon 5 with the place of the alcohol, right? So that way it's just one long
Mhm.
chain and it's
Yeah.
not facing down, it's just facing like one chain. And then the hydroxyl is facing down. That makes
Sure.
sense.
Yeah.
So number 5 will be
Oh shit.
and then
Yeah.
5 is
True.
so
Okay,
then
okay,
just kind of like make a circle like that.
Yes.
I
There
guess
she
it's hard to
goes.
explain, but
Sorry. Okay, cool. Yes.
if it's easier to visualize like that, you make a circle that it's easier to make a circle that way.
Yeah. Okay, cool. Makes sense. There we go. Okay, yeah. So it's a 5 carbon ring. So it's only one of these two. And then you aren't like losing any of your like dimethyls right here on 3. So yeah. So A. Cool. Okay. So then for 6, predict major products for each of them. So NABH3 is the weaker of the reducing agents. So that's, and then this one turns it into like an alcohol, right? Or OH.
Yeah, I think they would all turn
Okay.
to alcohol, like each
Oh yeah, I think
reaction,
they do.
yeah, all alcohols.
Okay. So the weaker one, which is NaBH4, reacts with the ketone, but it doesn't react with the carboxylic acid. So that one turns the ketone into an OH. H2, and then we would keep our double bond right here. But then H2 reacts with, here, wait, I'll just put like ketone. And then this one will react with the alkene, and it also reacts with the ketone. So that one is actually this structure. So yeah. Turns into OH also. And then this one's strong reducing agent. So it changes both of them into, or both the carboxylic acid and the ketone to alcohols. So, okay. Right. Or I feel like I might potentially be doing something wrong with the last one.
Is there 2 answers the same in all of these?
I did not. These ones A and B nearly look the same, but the alkene
No,
is there.
I mean for like her options at the bottom, she has A, B, and C for the A, B, and C.
Mhm.
And for for column A is A and C.
Uh-huh.
They're the same, right? I'm not looking,
Right,
I'm
wait.
crazy.
A and C. They're not the same. B is different.
Just for column A.
Oh, which ones?
Just column A.
Column A. Wait, no. Row A? Column A.
For the large A, yeah.
Yes, because well, because we're going like this. I was
right?
also very confused. Yes. So let's see. Our first one, we got the carboxylic acid. Yeah. So potentially this A and then this A, but we're going like through rows. So then you just compare it to the next one, which matches this one. And then the last one matches this one too. So it's row A. But yeah, these ones are also the same. And these ones.
Oh, I don't know.
Yeah.
Supposed to answer that. I just circled them individually for
Oh yeah.
columns A, B, and C.
Okay, cool. Well, and that's it for this one. But we do need this answer. Just highlight it. Okay. Okay, so that's it for the 2021. So then we could do the 2021. This one, I think there's a lot more that, yeah, we don't know, because it's on both sections. Yeah, I think this one we don't know how to answer, right? Stability of leaving group.
I think that's chapter like chapter 14, like the part we didn't get to in time.
And then, oh, this one we can do, I think. Predict the major products of the reaction.
I think this is
So,
also chapter 14.
do you think?
That's an acid halide, isn't it?
I think it might be, but
Because it's,
maybe true.
or is it a, would you just say ketone? I'm confused now.
No, I think it probably is one of those, because even when I was practicing it, I just mostly ignored this. But I don't know how it does actually react. Yeah, I think the CL is different, but I guess hypothetically we could do if it was a ketone. So then it's a Grignard's reagent. Oh, and there's two of them. I think it was supposed to react with the CL. Yeah, so Grignard's reagent. So it attacks, I forgot which part, I think just like this part. Uh-oh. It attacks that carbon, and then we get like a CH2 and a CH3 on here. And then this is kicked off. And then I'd have to like kind of redraw it. And then I think it gets well, it's with HCl, so this would take that hydrogen. So I think it would just be that, right? Oh wait, whoops. But also with the CH3, CH2. Is that accurate for Grignard's reagent?
Well, because I don't think it's a ketone. I think it's an acid halide.
I know. Yeah, sorry. I said hypothetically if it was a ketone.
You'd have to add 2 of the CH3, CH2. You're adding 2 of those R groups. So you just need to draw an extra line off of the end of your. So how you have an ethyl next to your OH, you need another ethyl. No.
Or another ethyl, you said?
The other one, yeah.
Oh, are we allowed to do that? I don't know. We are at the point.
No.
That's fine. I know, that's why I just kind of like cross this out.
It's gonna be the bottom one, all the way to the left, the second one at the bottom.
Okay.
No, to the left.
I'm just kidding.
That one.
Oh.
I believe that's the answer.
How did I get another one in there? Okay.
Because you're adding 2 R groups, not one.
Oh, I mean, yeah, probably. I would think it would also probably end up replacing the CL, but that's just because we did have a CL. I was thinking hypothetically without it. Yeah.
Oh, sorry.
Nah, it's cool. Yeah, otherwise I guess, but whatever. Yes, but we don't really know. But I guess this is just if it were a ketone. Okay. So yeah, that's kind of 2-ish. Number 3, predict the major product. I don't think that we're able to do this because it has what's it called? Ether.
Yeah, you'd only be able to do the reaction, well, like for the quiz with the carboxylic acid part.
Yeah. This one, I nearly thought this was going to be like one of the acid base reactions, but I'm not sure.
That's a an
Oh.
amine reaction with an ester and an amide.
Okay.
So
Cool.
that was, yeah, we don't have to do that.
Okay. Okay. Let's see. So the reagents that will complete this reaction. So for A, we're going from a ketone to an alcohol, but our carboxylic acid is staying the same. Oh, wait. Oh, well, I guess that doesn't really matter. This is an aldehyde. But yeah, aldehyde to an OH. So the weaker of the reduction or reducing agents. So it's either B or C. And then for this one, or for B, it's reducing both sides to OH groups. Yes. So H2 doesn't work for carboxylic acids. So BP. So C.
Just so you know, H2 and that metal can also do ketones and aldehydes.
Yes. Yeah.
Just in case, I don't know what her answer options will be.
It works on ketone. Okay. Cool. Oh God, that's all of them. Okay.
Did you do number 3 or did you guys skip over it?
We did not do number 3. I don't recognize this either way from anything we've done. Do you? With the
Well, I
H2?
looked it up and it's ethanol, and then the H2SO4 is from the Fisher acidification.
Oh.
Yeah,
But
you can only
yeah.
do the carboxylic acid side. The part where you have
Yeah.
the orange circle, that's an ether or ester, sorry. So we can't, for this quiz, it's not, I'm not supposed to do that. But I think the answer would be the second one on the top. I think the answer is that one.
So then what did you, so are you saying you would know what to do for this side, the carboxylic acid?
So with the Fisher acidification, that turns carboxylic acids into an ester. And then
What is that?
I think esters with an alcohol, just it changes to a different ester. So like that oxygen OR group will swap out with the oxygen and ethan, I don't know what you call it. It wouldn't be ethanol because the H wouldn't be attached anymore. It's just going to be the oxygen.
Yeah.
CH2CH3 would be the new OR group.
Yeah, so then was this specifically in the lecture notes?
In chapter 14.
Oh, in chapter 14.
But on the green
okay.
side, that's in chapter 13.
Oh, okay. Yeah, so then where is it? Do you know where it is in this one?
In chapter 13. Page 5, 13.5. Yeah.
Oh, okay. Oh, wait, so that's this, the ETOH? I guess so.
Mhm.
Oh, okay. Okay.
He has it written like that, random in random places. I don't remember where,
Okay,
but
interesting.
so
Okay
she,
then.
she has
Um,
used it, but
I see. And then it turns it to a where I guess. Okay. I'll leave that for now. That's kind of all for the quizzes. We could I don't know, go through concepts if you guys want. I feel like, well, no, I hope she'll go late on this because we're going so fast through everything.
we'll
Um,
ask her about number 3 tomorrow. She's got splaining to do on that one.
Oh yeah, the other number 3.
Yeah,
Okay.
I don't.
Yeah.
Do you have time if I have some question related this chapter 12 in exam 3? We had
Yes.
some questions we couldn't answer from exam 3, summer and spring.
Oh, so back to the other practice exam? The last one?
Yes, exam 3, summer 2020 and spring 2021. There was some questions that related to, if you remember. Yeah, exactly, number 3.
Mhm. Okay. Let's see. Can we
I
do this?
have
Oh,
a question.
this one I don't think we're expected to do still because this is still a what is this called? Not an is it an ester or what is the other one? Ether? I'm not sure the difference.
I think that's an ether, and ester has a carbonyl group.
Oh, okay. Well,
Ethers are just a oxygen single bonded. I
now we
think.
know.
Really sure.
Yeah. Actually,
We don't need
Yeah,
to
that's
know this.
yeah, we still don't know about this.
Oh, okay, great.
Yeah.
Thank you.
That one she never really. Oh, actually, did she go over?
Yeah, and
acidity?
question number 5.
Let's see if it's in the lecture notes, I guess. That is chapter 12. Oh, that's my homework. Let's see.
I think we can do that because it's called there. It's an acetyl from chapter 12 where we have hemiacetals and acetyls.
Oh, okay.
That's what we're supposed to do it as.
And then what's the acidity thing with that? Wondering where it says that.
What?
Because that one's asking which one's the more basic or whatever. What is it? Oh, why HB has a lower pKa than HA.
I'm looking at a different
Oh,
answer. I was
I
looking at
feel
a
like I still
problem,
don't know this
sorry.
then.
That's still you just find the conjugate base, so you'll have so you'd find the
Oh,
conjugate base, so like HA and HB are just acids, so yeah, they just be
okay. I feel like probably this one because it has. Oh wait, what? Which one has the lower pKa? I forgot what that means. Lower pKa is more acidic.
so I think, yeah, lower pKa is more acidic, higher pKa. So think you go off of resonance.
Yeah, okay. More resonance, more stable.
But why do we
Conjugate
decide
base.
decide
So
that?
this
Oh, because
one's
we're assuming
more.
the acids are the same, right?
What was that?
Because we're assuming the acids are the same, right? So that's why we're going off of resonance.
Yeah. Yes, and the charges are on the same atoms and everything. Just because I see double bonds, basically. Right. So I would think that this one is more acidic and has a lower pKa.
Yeah, I think she said it was that one. But
Okay, cool. Here's that. We didn't do this. We can do this side of it. So when it reacts with H2, we just I guess remember that it works to what's the word? Reduce the alkene and the ketone. So OH, and yeah, we keep that as an alkane. This one we still don't know. Oops. I don't even want to try 11 at this point. I don't think. Adding it. Oh, wait.
You have to turn it into a
Yeah. Okay.
Grignard
Yes.
agent.
Okay, so then yeah, if we were to do that, I think it would just be CH3 Mg 1 and 2 and then water.
I think it's just Mg, no? You're right, I think it's CH3. No.
Yeah, I think it does have to be attached to something. Because we're also adding like basically this.
You're adding an extra carbon.
Yeah. Yeah, so this would be MgBr, and then it reacts with the wait, what is this reactant? Acid. So it would have to react with like
Mm.
I'm not sure which acid would work with oh, H2O works as an acid, doesn't it? Oh, I'm confused now how to go through the whole problem.
Oh. Yeah, you can do, you need to, you do hydrolysis. So it's like, it's H2O and HCl, or H3O plus is what that makes.
Oh wait, should I use
It-
H2?
I would do H3O plus because it's H2O
Okay.
and HCl, which forms H3O plus. Like that's what the reagents, when it says H2O and HCl together, it's
Oh,
gonna
okay.
be H3O plus for hydro.
Oh, okay. So for the second step, or well, I don't even know how I would do this. I guess 1 and 2.
So you just, yeah, for the second step, you could just put like H2O comma HCl or whatever. I just put H3O plus, I think.
Yeah, or just H2O plus. Okay. And then it does here, let's see. This grabs this and then this breaks off. I think this is kicked off first or whatever. I don't know, it's not asking you to draw the mechanism at this point. So then we have, what do we have? Dun, dun. Uh-oh. Oh, and then it also reacts with the seal? Let me check. Okay, for Grignard, this is a reaction. Okay, yeah, so it does create an alkane. Oh, well then I guess I just am not sure what to do with it after the fact. So now we're at this alkane, right? But we want to add an OH over here. I have no idea how to get it over here anymore.
What I originally did was just add an Mg, add magnesium, and then I added a carbonyl, like I can't remember what it's called. I think I added formaldehyde is what it's called. It's just like C double bond, and then there's 2 hydrogens. So like.
Oh yeah, I see. Oh, instead of the CH3.
I think that's what I was like. I thought you were able to do it the way you're doing it, but I guess.
Okay. So then, so that would One like that. Is that we?
So, well, it's gonna, so when the Grignard reagent reacts with the,
This thing. BR.
sorry, let me go to my thing. So the double bond for the oxygen is going to break when the, well, you have to erase the H2O HCl right now. I think that's what's confusing you. So yeah.
Okay.
So delete that. Just delete the, yeah, just make your, so do the reaction with magnesium. So you'll just add Mg between the Br.
Okay. Oh, okay. I see. Okay.
You have to draw, you're missing a carbon.
True.
Are you?
Okay. Yeah.
I actually don't know. 1, 2, 3.
Okay.
Okay. So that bond with the magnesium is going to attack your the carbon in your carbonyl,
Uh-huh.
and that double bond is going to break and become a lone pair on the oxygen.
Okay. I want to make sure I do it right.
So then you get that weird little intermediate.
Is this what you have also? Oh, sorry. With it, it's an aldehyde, I guess.
You got to get rid of the extra bond on the oxygen because that's a lone pair now.
Oh yeah.
So it's gonna be why do you have that hydrogen there? That's throwing me off.
Oh, because it was you said what is this, formaldehyde? I thought.
Yeah, but you're just
Or do you want to
yeah,
do like
but
no
it's-
thing right
there's
here?
no, but you're not doing anything with the hydrogen. It's a carbon
True.
adding
Okay.
on.
No use. Okay, true. Yeah, because then we
If you're
killed the double
adding
bond anyway.
on that carbon
Mhm.
like that, yeah.
Okay. So then we'll do this. Oh, is this already the end?
Yeah, that's
Oh,
right.
cool. Okay. Cool. Wow. Oh
So
shit.
you did it
Oh,
right. You
I
did it
just
wrong.
lost. Okay. Okay. Cool. That was.
Are you still there, Desiree? Is it me or am I frozen?
No, I could. That's
I can hear you.
Oh, okay. I think maybe Desiree froze. Mm. Oh, there you are.
Okay, wait. I'm scared. Yeah, I think that my thing just froze. Anyway. I guess it's kind of it. Anyway.
Question number 7, part C.
Number 7. Oh, pretty. Yeah, we can do that. Here. Let me join again on my iPad then.
Massachusetts Global is a better university. We are leaders in teaching adults the skills they need to better their lives.
Okay.
Programs, expert instructors, and outstanding support and better student satisfaction. With a better online.
I gotta head out, guys, but I'll confirm that number 3, like have her
Yeah.
explain it at least so we can understand how to do it, because it make no sense.
Sounds. Yeah. Okay. Okay. Sounds good.
Right, bye guys.
Thank you.
Bye, thank you.
So then for C, it's a Grignard's reaction. So what happens is, I believe it's just this one comes down and attacks. Here, wait, let me go ahead and see if I can get the steps. Give me 1 second. Okay, because I don't want to lose any bonds or anything. Okay, let's see. So this one comes down and attacks here, and then we end up losing our double bonds. So we just end up with, let's see. I'll keep this, and then we add on the CH3, CH2. Oh, actually CH2 again. So I'll add one more. So there's that, and then this ends up turning into an OH. Let me move it over there. So yeah, as this double bond comes off, so our intermediate is like this. Oh, and it's negatively charged, and then it reacts with the H3O plus. Yeah, and it grabs the oxygen. So yeah, I believe that this is a product that we end up with. I don't know if anyone can confirm just the amount of carbons in this chain. Should be 3, I think.
Yeah, because a new carbon-carbon bond is formed. I think that's right.
Cool. Sounds good. Cool. So yeah, here's that one. You're basically just adding everything except for this very last part when you do the
Thank you
Grignard's
so
reaction.
much.
Cool. So yeah, that's mostly all of them. Let's see. Guess there might be some on the other practice exam that we were gonna do. Let me see if I can find it. 2021. Yeah. So if we want, we could go ahead and do a couple from the 2021 exam that we couldn't do. So for this one, just naming. So we'll start with the aldehyde, 2, 3, 4, 5. So pent and al for the aldehyde, and then we'll do, let's see, 3 oxo, and then we also have 4 bromo. And then in alphabetical order, 4 bromo, 3 oxo pentanol. There's no cis or anything like that. And also no RNS, because we would need to be shown the like wedges and dashes or whatever. So I think that's it for that one. Yeah. Okay, for number 2, let me see. Go from, let's see, an aldehyde to OH. Thinking. Oh, okay. This one is, well, it could be either of them. I want to check on both of them. Because there's NABH4, and then there's also another one.
I mean, Isla put a gem in her mouth and then she put it out.
برو همه.
Okay, so NABH4, and then let's check the other reagent for that one. Oh, okay, and then ether, and then H2O. So I'll go back. Okay. So that's how you get to that one. For this other one, I'm not too sure, because it just reduces the alkane, but I'd have to double check, because I thought H2 also reduces the the aldehyde. Yeah, I think it does.
Then we have primary alcohol, and I'm not sure, this is my answer. We can use PCC, it's turned to the aldehyde.
Wait for, we're actually going the other way, but yeah, if we were going that way, I think PCC does work. Yeah, as long as that's the rule for primary alcohol. Yeah, I don't have it in front of me right now, but yes, that would work going the other way, but for the left side, we were going to the alcohol. So then I used NaBH4 ether and H2O. And then you could also use the LiAlH4. And then let's check. Yeah, because it turns it into an OH. And then this side, I'm honestly not too sure, because it only reduces the alkene.
Well, I think I understand what Roshan was saying. So like you'd have to reduce both of them, but then you'd be left with an alcohol for where the aldehyde was. So you can make that back into an aldehyde using, I think it was PCC.
Yeah. Yes. Right. If we're going back this way.
Yeah, it's just like a multi-step thing. So first you'd have to reduce them both, but then you can like unreduce it back to the aldehyde so that you.
Oh.
Yeah.
Oh, okay. So then the first step is the H2?
Yeah, you could use, I think, H2 or the NABH4. They both work
Yeah,
to
I guess
reduce.
so.
Or sorry, no, it would have to be the H2, you're right.
Cool. Okay. And then, yeah, so the second step that we do PCC to go back from the alcohol. So true. Okay, cool. All right. Okay. Yeah, so there's that one. Other ones we haven't done. Circle the compound with the higher boiling point. Yeah, she didn't say we had to do this one, but we know it's A because this is only a hydrogen bond acceptor. Oh. And then this is a donor and acceptor. So there's that one. Don't think we do A. We can do B. Okay, so then for B, let's see. So for this one, we have this ketone, and then we also have an alcohol. And then in the rules for Grignard's reaction. If you have an alcohol within the structure, it'll be no reaction because it ends up like reacting with itself and then like destroying itself when you have an alcohol in it. And then let's see, hypothetically, if we didn't have an alcohol, just to do it, double bond O, 1CH3.
Would you please explain why there's no reaction?
Yeah, and then we could try and find it in the book. I just know that for Grignard's reactions, they react with like ketones and aldehydes, but the OH in the structure, it ends up reacting with it and then destroying it. Let's go ahead and just look and see where we can find it. This is still my homework. Okay. So this is Grignard's. Okay, so this is also showing the second half of the reaction where it's protonated. I wonder if, so this was just like in her example, that the OH will destroy it. And also because the following functional groups will destroy Grignard's reagents. I don't think that she actually shows us the, what's the word, the mechanism for why it destroys it, but we have an alcohol within our thing. And if we have like a carboxylic acid in it also, it'll be no reaction. So yeah, that's kind of why.
Thank you.
Yeah.
What is the page of this?
This
Chapter.
is page 5.
Thank you.
Erase that. I don't think that I know this reaction. I don't know if anyone else does. Yeah. I don't know if we went over that one. Technically should have, but oh god. Okay, so this one is provide a mechanism that we could do. So for this one, let's see. I'm gonna get my Quizlet out so that I have these steps, and then I'll write them down. Okay. So the steps for it are nucleophile, which is the Grignard attacks, the electrophile, and then let's do double bond moves to a lone pair. I guess. Okay. So for this one, the complete mechanism would be, we'd show this positive and this one negative, I think. And then it grabs from here, here. And then it kicks off the double bond. So then the intermediate. Okay. So that's like the first half of the reaction, and then it reacts with H3O plus. And it grabs a hydrogen and deprotonates. Oh, sorry. And then I didn't show you add the CH3, CH2 right here. So that's a ethyl or whatever. So and that one turns into yeah, and then that just gives the final product. Oh. Okay. So yeah, that's number 9. And I believe that's all you have to do to show your work for it too. Yeah. And that's the end of that other exam too.
Thank you so much.
You're welcome. Okay,
Bye.
bye. Cool. Okay. Good luck. Have fun. And then I'll upload the recording as well. So yeah.